Okay, so to solve these algebraically, we'll choose to get rid of a's because they have opposite signs, right? And we could have as easily chosen to get rid of the b's. It really doesn't matter, okay? But what I'm going to do is I'm going to multiply the first equation by 5 and the second equation by 2. That'll give me a 10 on the a here and a negative 10 on the a here, right? So I do the first equation and multiply it by 5. You don't necessarily have to write this out, but I kind of recommend it. And I'm going to do the second equation and multiply it by 2. And that's going to give me 10a. And you've got to remember to multiply everything, including the number on the right-hand side, by the same number, right? Otherwise, you change the solutions to the equation. Okay? But multiplying everything by 5, this equation has identical solutions to this one. If A and B satisfy this one, they'll satisfy this one, and vice versa. Okay? That's important to understand, just to get the idea of the theory. Okay, well anyhow, we're going to get here negative 10a plus 35b equals negative 10. And then we're going to add. Very simple. Because now we see that we've set it up so that the a's are equal and opposite, and when we add, we're going to eliminate a. And we're going to end up with 50b equals 35. Okay? And then we solve for b, and I'm not going to go through the details of that. It's 7/10. 35 over 50 reduces to 7 over 10. And I don't use decimals, although with the flow data, it's totally okay to use decimals as long as you use enough significant figures, and I'll talk about that. Okay? We okay so far? Okay, well, we've eliminated a, right? And now we can take this value of b and plug it into either one of our original two equations. We go back to the originals. Now, well, these might not be the originals because we got an a, b, and a c. We got 3 equations in a, b, and c to start with, right? Okay? So this is what we get when we eliminate c from those 3 equations, and we'll talk about that again in just a minute. But for the flow model that we're doing right now, it's really easy to do that. Okay? Okay. So, anyhow, we get b equals 7/10, and I'll bring that back to either equation. I'll just go to the first equation, and that gives us what? It gives us plugging this in here and then bringing the equation down. We still have 2a, and that is plus 3 times 7/10 equals 9. Now, how do we solve that? Well, I'm going to go one more step, and then I'm going to do something that you might not do. 3 times 7/10, as you might suspect, is 21/10. If you don't know how to multiply, divide, and add and subtract fractions, review it. We talk about it in the MCR, so there are videos that address that if you need them. Okay? So we got 2a plus 21/10b equals 9, right? What do I do with that? Well, you might say, well, subtract 21/10 from both sides, right? Well, do you love doing fractions as much as I do? I don't mind doing them, but they're a little more complicated than what you would get if you had whole numbers. So now I multiply by 10. Meaning I multiply by my denominator here. And I get 20a plus 21 equals 90. Isn't that a lot nicer than this?
Oh, yeah.
Okay? Now, if I've got decimals, you know, if everything's in decimals, then it maybe doesn't make that much difference, although there are things that we do there that I'll show you. So this gives us 20a equals 69, so that a equals 69 halves. And these are exact solutions. Okay? Well, 69 halves is equal to 34.5. Because we're going to do a graph here in a minute. And when we do the graph, we want numbers that we can plot. So 69 halves, once you get the exact solution, you can do a decimal approximation. That's not even an approximation, that's exact. If it was 69 over 7, then you get, what, 7 and 5/7, 7.71 something, okay? And you would have to use an approximation. And we'll talk about how you approximate these numbers. And of course, this is 0.7, and I don't necessarily have to write that out. Okay, well, to check to see if our solution makes sense, because I'm not at all sure that it does, I suspect something is seriously wrong here, which means I suspect I made a mistake, but I never make mistakes, so that couldn't be it.
I think
It's just, didn't you?
Oh, it's over 20. See? I pretended to make a mistake, just say somebody pointed out. Okay, now it's 3.45, and that makes a whole lot more sense. Because if I plug 34.5 into here, there's no way that's going to match up with a 0.7 value of B and give me a 9, right? 2 times 34.5 is 69, and 3 times 0.7 is not going to match up with 69 and give me 9, right? Okay? You want to think about the numbers, because you could easily do that. Now, I really did make that mistake. I wasn't just pretending, but let's take advantage of the fact that I made a mistake, because sometimes you do too. Check it with common sense. So you always check your solutions. Now, 3.45 multiplied by 2 is 6.9, right? And 3 times 0.7 is 2.1. And 6.9 and 2.1 is 9. Whether you can do that in your head or not, you can check it, right? Or you can at least check numbers nearby and make sure it makes sense. Okay? You know, if it was 3 and 1, which are the closest integers, you'd get 6 and 3, which is 9. Just coincidentally, it works out. So that's pretty good. And you get, what, minus 15 and 7. Well, that's like minus 8. That doesn't work. That doesn't look all that great either. Let's see. 7b is going to be like 4.9, and 5 times this. It still looks like there's something wrong here.
Shouldn't, I think you multiplied the 5.
Yeah, it's supposed to be 14.
14b.
And then negative 4.
Okay.
And
Yeah,
so negative 10.
negative 4.
Oh, it's 2 times number 2, right? And I multiplied it by 5. And then I multiplied this by 5 because I multiplied by 5 up here. Okay? So I really screwed up. And everything worked for the first equation, but it didn't work for the second, which illustrates why you check things. I really did screw that up too. That wasn't just pretend. Okay? But it works out much better now that you see why you check, because it's real easy to screw up. Now, you know, being 100 years old, I'm more prone to screwing up clerical things than you are, which is why I'm really good at checking and resolving, because there are a lot of bugs in my solutions, okay? And there's one right there, okay? Now, so if I fix this, just to show you that I really can solve these problems, I get 14 here, and I get negative 4 here, right? Which gives me 29b equals 41, right? So that now b equals 41 over 29, and now I've got to have 41 over 29 here, right? Okay? And 3 times that's 123, so it's 123 over 29. And let's see, that's probably not Yeah, that's still 9, but, well, yeah, because that's in the first equation, okay. And then I've got to multiply by 29. It's so convenient to just multiply by 10. I like the numbers I use much better. But you can't just go with what you want it to be, you got to go with what it is, right? Okay, so you drag me kicking and screaming back into a correct solution. And I'll multiply by 29, which is going to give me 58A plus 123 equals, oh good heavens, 263. No, wait, 29, 261. Boy, that would have been a terrible mistake. Okay. Okay, and then we subtract 261, so 58A equals 138. Check me. 138 over 58, which reduces down to 69 over 29. That has the ring of plausibility, and that's approximately equal to 2.3, and maybe between 2.3 and 2.4. I'll go with the 2.4, but I kind of think that's right. Okay, and this 12/29 is almost like 12/30, which would be 0.4. So I'm going to say that's approximately equal to 1.4. Okay? Now, 2.4 times 2 is 4.8. That's going to give me 4.2. 4.8 and 4.2 is 9. Now, those aren't exact, but if you got the exact numbers, they'd work out. Okay, if we use the fractions to be sure that it's really right, because the fractions are what's really right. These are approximations, aren't they? Okay? Then, let's see if my luck holds out in the second equation. -5 times 2.4 is -12, and 7 times 1.4 is 9.8. -12 plus 9.8 is -2.2. So it comes out close but not exact here. With my round off, I just lucked out and it came out exact up here, but you don't expect that. Okay, do we understand the process?